Alright, we have here another law of sines or cosines problem. We take a look at this one, and it's a little bit simpler in some ways to kind of pick out what to do with this one as opposed to my last video, simply because we're given all of our side lengths. I look here, it says a bridge is supported by triangular braces. They have lengths of 63 feet, 46 feet, and 40 feet. And they want the measure of the angle opposite the 46-foot side. So, one of the very first things we saw with law of sines was that you must have at least one angle. Now that I look at this problem, I can immediately eliminate law of sines as an option. The difference from this problem and our last problem is the version of law of cosines we're going to look at. For side angle side, you're often asked to find the other side length, and that's what we did in our last video. But here, we're asked to find the measure of an angle for this particular problem. So we're going to use an alternate form of law of cosines. And by alternate, I just mean a rearranged form. I should say that. All we're really going to do is say, look, we have a triangle. In fact, I'm ignoring the premise of the problem, really. I'm just throwing out some values here. I don't even really have to draw this, to be fair. I'm just kind of making a note here that the angle opposite the 46-foot side would be over here. This would be the theta that we're looking for. But ultimately, this triangle is not very useful, in fact, not very accurate, because it's supposed to be triangular braces for a bridge, so bear with that. But we have an alternate form for finding an angle where we say that we can take cosine inverse of a whole lot of stuff. And the way I kind of pushed this forward to remember first was you always start by squaring the side opposite the angle you're looking for. So we're going with the 46 squared here. And then we just subtract the squared version of our other two sides. So that doesn't really matter what they are. Or rather, not what order they're in. It does matter what they are. And then on the bottom of the fraction, it's always negative 2 times those other two sides that we care less about. So the top is always the side opposite your angle squared minus the other two sides squared divided by negative 2 times those other two sides. So the 63 and the 40 are the two that were on the end here. And honestly, for all the talking that I've done and all the, kind of slow build up here, the actual work to this problem is fairly straightforward. Now in our last video, I'd already changed this over to degree mode, so I'm just going to leave that way. And we're going to go through and we're just going to plug this in very carefully. Now, I have the benefit of this type of calculator being able to set up a fraction bar so I can avoid a lot of things. If you're trying to plug this all in a single line, keep in mind that it might be good to stick an extra set of parentheses around the top and the bottom here. It gets messy to do it that way, but it's more appropriate. If you forget the parentheses on the top, it'll mess you up. But if you're in Desmos or you're on this kind of calculator and you have the ability to put in a fraction bar, then go ahead and do it. It'll save you a little bit of typing, it'll save you a little bit of hassle, and you don't have to worry as much about whether the calculator misread what you intended to write. In fact, on the bottom there, I like to, instead of using parentheses, I like to type into the calculator multiplication symbols just because it shaves off a few extra buttons to press. And then this is also easier to check to make sure you plugged it in correctly because you can see this direct form, this direct parallel between the two. And that looks pretty good to me. Make sure, by the way, that on the bottom here, you're putting a negative sign, not a subtraction sign. If you put a subtraction sign there, the calculator will usually freak out. And here we have, let's say, about 47 degrees. It didn't tell us how to round, and I personally just like to round angles off to whole numbers. That's not for any particular major reason, it just feels nice to me.